Hello students, my name is Amir Kumar Bishoyi. Thank you for your support and love and affection for my previous section. It's given inspiration for me to extend my ideas. So now the topic, hybridization. In the last class I told you the definition and the application of hybridization. Again the definition. The definition is the intermixing of orbitals, atomic orbitals. Because hybrid orbitals involves the terms s, p, d, l. These are the atomic orbital terms. So the definition, it is the intermixing of atomic orbitals which is associated with a similar energy to form same energy orbitals oriented in a specific direction. And the second one, the molecule formed through hybrid orbitals is more stable due to enhanced overlapping. And the most important thing, hybridization predicts geometry. And the geometry is up to two types, that is regular and irregular. Regular means only bond pairs, symmetrical repulsion. Because all are bond pairs, so all have similar kind of repulsion. The structure have symmetrical repulsion. And the second one is irregular. Irregular means some distorted in the regular structure due to presence of lone pair. Let us take an example for a regular geometry, that is BF3. BF3, there are three bond pairs. This is a bond pair, this is a bond pair, this is a bond pair. They have similar kind of repulsion. So the structure have symmetrical repulsions. So the shape is trigonal planar. The shape is trigonal planar. These are the three hybrid orbitals, sp2, all are bond pairs, so they have symmetrical repulsions and the bond angle is 120, the geometry is trigonal planar. Now I discuss about irregular geometry. Irregular geometry means presence of both bond pair and lone pair. Why irregular geometry? Why distortions in a regular structure? Because I just want to focus on one thing, that the lone pairs occupies more space, more volume in any structure. The lone pair occupies more space, so they have a more repulsion as compared to the bond pairs. When I take bond pairs, three bond pairs, they have symmetrical repulsions. In case of bond pairs, if the structure have a lone pair, definitely the repulsion is different in this structure. This is a bond pair, this is a lone pair. Here you focus that these two are bond pairs, this is a lone pairs. They haven't similar kind of repulsions. The structure is not regular. Due to this presence of lone pair, which occupies more space, so it more equal to the bond pairs. So that definitely the three bond pairs are like that. They have a similar repulsion. The structure is like that. Instead of a bond pair, there is a lone pair which occupies more space. So the bond angle between the bond pairs decreases. The structure is like that. It is a V shape, or reverse V shape, or bend shape, or angular shape. So this is the difference between a regular geometry and a irregular geometry. Geometry is of two types, regular, irregular. Regular have only bond pairs which have a symmetrical repulsion, but irregular have both bond pairs and lone pairs. Because it has both bond pairs and lone pairs, so it's not a symmetrical repulsion. So the structure is distorted. So for regular geometry, this is trigonal planar, and for irregular geometry, this is V shape. Next I tell you one thing. What is the difference between a geometry and a shape? Geometry, we calculate both bond pair and lone pair. But shape, except lone pair, the structure, how it looks. Okay? Geometry is trigonal planar. But whenever irregular geometry, the structure looks like that when a lone pair is present. It is a V shape. So this is a shape. So what is the difference between geometry and shape? Geometry, we taking the bond pairs and lone pairs both, but in shape we excluding lone pairs, how does structures look out? This is self. Okay, it clearly understood the irregular geometry by taking the comparison between regular and irregular geometry. In regular geometry, the CS4 methane molecule, the hybridization sp3 self is tetrahedral, and for regular geometry, I already told you that geometry and self are equal because there are no lone pairs. So for sp3 tetrahedral self, bond pairs are 4 and lone pairs are 0. This is the structure. I already told you this is the structure of tetrahedral. When 4 bond pairs are there, for maximum separation and least repulsion, the angle is 109.28. Now, I compare that geometry when I put a lone pairs instead of bond pairs and the irregular geometry. Okay, these are 4 bond pairs. When I take out the bond pair, I put a lone pair instead of that bond pair. Now, the symmetrical repulsion is now not here. This is the asymmetrical repulsion because the structure have both. These are the bond pairs. Maybe they have the similar repulsions, but that lone pair that is different from that bond pair. So now the structure is distorted, and this after excluding that lone pair, it looks like a pyramidal self. So when I take an example like NS3, there are 3 bond pairs and 1 lone pairs. So the self is pyramidal, and due to presence of that lone pair, which occupies more space, it repels more as compared to bond pairs. So the bond angle is decreases as compared to the 4 bond pairs bond angle. When I take methane molecule, the bond angle is 109.28, but here the bond angle decreases, that is 107.3. Now I take water molecule. In water molecule, another lone pair inserts in the place of a bond pair. Again, 2 lone pairs, 2 bond pairs. Definitely it is a means due to presence of lone pair, the structure is distorted, and now the bond angle again decreases. So the angle is 104.5. Okay, fine. Now I compare with sp3d hybridization with 5 bond pairs which are regular geometry. I told you earlier when sp3d 5 bond pairs are there, that is a trigonal bipyramidal structure. Trigonal bipyramidal, say triangle, and it is a bipyramidal structures. And there are 2 sides. One is equatorial sides and this is axial sides. The angle between equatorial sides is 120 degree and axial and equatorial side is 90 degree. Now I compare the irregular geometry with regular geometry. 5 bond pairs, trigonal bipyramidal structures, 5 bond pairs. When I put a lone pair, insert of a bond pair. Insert of a bond pair. There is a lone pair. As usual, 4 bond pairs, 1 lone pairs. The shape is seesaw and the angle decreases from ideal angle. The equatorial ideal angle in a regular geometry is 120. Here decreases, that is 118. And the equatorial axial angle, that is 90. Here 89. As usual, when 2 lone pairs are inserted instead of bond pairs, the shape is called T shape. This example is called CLF3 and the angle again decreases and decreases. If I insert 3 lone pairs instead of 2 bond pairs, angle again decreases and the shape is called linear. And I will take an example like XCF2. This is a linear structure with irregular geometry. But there is a question. In trigonal bipyramidal structure, no doubt we place lone pairs instead of bond pairs, but the lone pair occupies which position, axial or equatorial? So this is the trigonal bipyramidal structure. Okay. Then for 5 bond pairs it is regular cell, and including lone pairs it is irregular cell. But there is a question. In trigonal bipyramidal structure, if there are lone pairs, at which position this lone pairs occupies? There are 2 sides because axial and equatorial. Please imagine that. If I place a lone pair on axial position. If a lone pair placed on axial position, what is the angle? Axial equatorial 90, 90, 90. Okay. Compare. Please focus on that. If a lone pair is positioned at equatorial position, 130, 120, 90. For axial position 90, 90, 90. For equatorial position 120, 120, 90. So what do you think? When a lone pair is placed in equatorial position, it suffers from less repulsion because for equatorial position it is 120, only for axial position, for one axial position it is 90. Okay? When compare, when the lone pair placed in axial position, it suffers more repulsion because here is from 90, here is from 90, here is from 90. So, what I want to say, in trigonal bipyramidal structure, when a lone pair is placed, definitely at equatorial position or suffering less repulsion. This is a trigonal bipyramidal structure. If the lone pair is placed at equatorial position, it suffers less repulsion because equatorial is 120, equatorial is 120, for axial 90 degree. But the lone pair is placed in an axial position, it suffers from more repulsion due to here 90, here 90, here 90. So, in trigonal bipyramidal position, what I say, the lone pair is always placed at equatorial position due to less repulsion. So, this is the trigonal bipyramidal structure in a regular geometry. When I insert a lone pair, that should be at the equatorial position. Okay. When lone pair is there, definitely it deviates from ideal angle, that is 120. We calculate the bond angles. Okay. So equatorial angle in ideal 120, here 118 and 89. When I place like two lone pairs in CLF3, two lone pairs, that should be at equatorial position. Angle again decreases from ideal angle. And now focus on that. When I place in three lone pairs in XCF2, there should be at equatorial position. But what if focus that they are in three equatorial position, three lone pairs, there is a symmetrical repulsion. And axial to axial, they are two bond pairs. So the angle between this bond pair and bond pair is 180 degree. So angle between bond pair and bond pair is 180 degree. Okay. I want to explain in octahedral geometry what is the irregular shape. In octahedral geometry, there are 6 bond pairs. The bond angle is 90. Now I place the lone pairs in irregular geometry instead of bond pairs. Okay? But there is a question also. This is a plane. 4 atoms. These are 2 atoms. Out of the plane. Lone pair is always placed out of the plane. Okay? So in square pyramidal geometry, there are 5 bond pairs and 1 lone pairs. So I put a lone pair instead of bond pair at the out of the plane. Now, in the second one, for square planar geometry. Okay? In octahedral geometry, there are 6 bond pairs. In square pyramidal geometry, the lone pair is out of the plane instead of bond pairs. And in square planar geometry, there is again a lone pair at the out of the plane. Okay? So 4 bond pairs at the plane and 2 lone pairs 180 to each other and out of the plane. Fine. Next one. Next one is SP3D3 at a pentagonal bipyramidal structure. Pentagonal bipyramidal structure. Pentagonal bipyramidal structure. 72 degree and 90 degree. 72 degree and axial 90 degree. I placed a lone pair at pyramidal. At pentagonal bipyramidal share, I should place a lone pair instead of bond pairs. Okay? So the geometry is pentagonal monopyramidals. In XCF6, we should show that the pentagonal monopyramidal structures. So I hope you understand properly that geometry, regular geometry, irregular geometry. Regular geometry have only bond pairs. Irregular geometry, both bond pairs and lone pairs. Regular geometry, asymmetrical repulsion, asymmetrical structure. But irregular geometry, due to presence of lone pair, the structure is distorted, so it is an irregular structure. Okay? In tetrahedral geometry, in trigonal bipyramidal geometry, in octahedral geometry, in pentagonal bipyramidal geometry. In tetrahedral geometry, 4 bond pairs are there. There is a regular geometry, and shape is also tetrahedral. But when lone pair puts instead of bond pair, there is a irregular geometry. For one lone pair, the shape is pyramidal, but geometry is tetrahedral. For two lone pairs, the shape is V-shape. Because what is the difference between geometry and shape? Geometry includes lone pair and bond pair. But shape includes only bond pairs. Excluding lone pair, how the structure look like? In trigonal bipyramidal structure, the lone pair is present always at equatorial position. Why equatorial? It suffers from less repulsion. When it placed at equatorial position, equatorial angle 120 and for axial 90, 120 and 190. But when placed at axial position, it all 390s. So it suffers maximum repulsion. So what do you note that? In trigonal bipyramidal structure, the lone pair is present always at a equatorial position. In trigonal bipyramidal structure, it is a regular geometry. When one lone pair is placed, that is C-shape. Two lone pairs are placed, that is E-shape. Three lone pairs are placed, that is linear structure. And all are irregular geometry. The bond angles are deviated from the ideal angle. Equatorial 120 ideally, here less than 120. Equatorial axial 90, here less than 90. Now in octahedral, there are two irregular shapes. Geometry octahedral, but shapes too. Irregular shapes. What are the shapes? Square pyramidal, square planar. Square pyramidal, one lone pair is put instead of one pair. That is always out of plane. Because at plane we put lone pairs, it suffers from maximum repulsion. Okay? When two lone pairs are put at square planar structure, that is out of plane and 180 to each other. Because we know that we place the bond pairs, lone pairs for maximum separation and least repulsion. Fine. Then pentagonal bipyramidal structure, we put a lone pair instead of bond pair at axial position, 72 degree and axial 90 degree. I placed at axial position the lone pair, and the shape is called pentagonal monopyramidal. I hope you understood properly what is hybridization. The intermixing of atomic orbitals is associated with similar energy to form a same energy oriented in a specific direction. Fine. The covalent and coordinate compounds, they have hybridization. Hybridization predict geometry, regular geometry, irregular geometry. Regular geometry for two bond pairs, say 3, 4, 5, what are the bond angles? For irregular geometry, what is the difference between regular geometry and irregular geometry? In irregular geometry, what is the difference between geometry and shape? Okay, fine. And for more updates, subscribe my channel, The Science Source, a quest of knowledge, that is a source of knowledge. Thank you.